Hi there, and welcome to our presentation about Inkscape. My name is Isar, and together with Wessel, Suraf, and Vivian, we'll give you a short presentation about this application. I'll start off by talking a bit about what Inkscape is actually used for, and also introducing their product vision. Next, we'll get a bit more technical, and we'll talk about the architecture. Next, talk a bit about variability analysis, and we'll finish off with a talk about the technical depth. So, what is Inkscape actually used for? Now, Inkscape is a vector image editor. And vector images are images where the rendering is based on mathematical equations instead of pixels. The advantage of using mathematical equations over pixels is because when you zoom in a vector image and you use mathematical equations to represent a line, this line will just stay the same, right? Because it's just a mathematical equation. While with pixel-based images, if you zoom in a lot, it really starts to have some jagged edges and you lose a lot of resolution. An added benefit of vector images is also their small file size, which makes it really suitable for applications on the web, for example. And the file format that is most often used is the SVG format, which is also the format that Inkscape supports. Now, the vision behind Inkscape is to be as open as possible, such that different people with different backgrounds and different ideas can all collaborate together, both on the artistic side of things, but also on the developer side of things. Because the goal of Inkscape is that a lot of different people come with different ideas of what Inkscape should be about. There is a board of developers from Inkscape, but they do not want to dictate which features should or shouldn't be in Inkscape. And as a result of this, Inkscape has a lot of different functionality, and it's used in a lot of different use cases. For example, it's used a lot in CNC cutting or latex generation or for comic book design. So by being very open, Inkscape has a lot of different functionality, which is really something that the board strives for. Next, we'll talk a bit more about the architecture of Inkscape.
Thank you, Isar. Inkscape is a mostly monolithic application, making its container view a bit dull. So let's take a look at its components instead. Inkscape is built based on the model view controller design pattern. The document components, which you can see here in red, is the model. It contains a representation of the SVG file being worked on. The display, just below the document, is the main view. It renders the vector graphics to a canvas and represents it to the user through the use of the GUI. The tools and extensions are the controllers. These apply transformations to the documents, like adding shapes or blurring colors. These tools and extensions are also responsible for loading and storing files to the file system. On top of the model view controller structure, there's an additional layer consisting of the application's user interfaces, the command line interface, or CLI, and graphical user interface, the GUI. These provide users intuitive access and a generalized view of the underlying controllers and views. All these components are connected through the use of observers, meaning that each component interested in another component lets them know about it, and components that change notify the interested components of that change. The goal of these separated components and flexible approach to connecting them is to provide customizability and, more importantly, extensibility.
Thank you, Wessel. Let's talk about the variability in Inkscape. So Inkscape offers a lot of different variability. The most obvious being the platforms that it is supported on. It works on all three major platforms, Windows, Linux, and macOS, and each of them have well-defined distribution channels through which a user can install Inkscape. Coming to the compilation options, Inkscape provides different configuration aimed at both end users and developers. Feature options such as changing interface language, enabling raster transformations, and extending diagram support gives a user essential and useful variability. Developer-specific options such as profiling, address sanitization, fuzzing, and choice of C++ standard makes Inkscape both flexible and also easy to contribute to. Similarly, GUI also provides access to different themes, icon types, language translations, and color schemes, which may seem trivial, but from a context of a vector graphics editor, it forms an important aspect. Extensions are the biggest source of variability for Inkscape. It allows users and developers to create and use any form of extended functionality that they want. The process of adding and using new extensions is really easy, and there are a lot of them available in the Inkscape gallery, ranging from pattern generation to designing laser-cut jigsaw puzzles. A user can find a great variety of functionalities to explore. These contributions are highly encouraged by the Inkscape team. They do realize that it helps Inkscape achieve its vision of being highly community driven. Also, it makes Inkscape stand out as a graphics editor. Now we can look at the technical debt.
Unfortunately, not everything about Inkscape is as well architectured as the extension subsystem. The development of Inkscape began in 2003, and the project is tied down to the decisions made over the course of 18 years. Inkscape's roadmap has been driven by the user's requests for features and fixes. Development may begin without the consideration of the yet unknown future goals. Inkscape typically plans ahead for only one release, requiring future releases to redo the previous work. An important source of technical debt in Inkscape is the use of many tightly coupled components. In such designs, any change in one component affects the other, and hence they are less suitable to change. The effort required to maintain such a design is high. The source code documentation of Inkscape can be significantly improved as well. Many files are lacking documentation with comments or explanation. For instance, Inkscape uses signals as a connector with little to no documentation, making it confusing to understand. The focus of Inkscape is not on testing, with test coverages figures rather low. The present coverage is about 13% for lines and 6% for branches. We suggest including a test case for new features and fixes to improve the stability of the system and to reduce the future maintenance cost. There is also no documentation describing the project's architecture, and Inkscape's architecture described on their wiki page is outdated. The file structure of the source code does not always reflect the architecture of the application either. All of these reasons make it difficult for further development to take place, as the contributors require more time and effort to understand the working of the project. In conclusion, Inkscape is a project for digital art using vector graphics, but is rapidly expanding in many directions. Due to the wide range of extensions available, the project can be tailored to suit the needs of different types of users. Inkscape's architecture has changed a lot since it was forked from Sodipodi in 2003, and a large amount of refactoring has been done. Due to the accumulated technical debt, some parts of the codebase might be hard to understand, but it is very impressive that a group of volunteers has managed to build and maintain such an extensive and ever-evolving project. This truly speaks to the capabilities and passion of the developers. By ensuring that the development environment is friendly and mentored, where contributors can help each other and ask questions, they establish a solid foundation for future development.